Hello friends, as we have seen in the previous video that compiler is having many different phases with the help of which high level language is converted into the assembly code, right? We have seen that in the previous video. Now in this video we are taking an example, a small example, so that with the help of that example you can understand very clearly that what all the phases are doing and how exactly it is doing, right? So here I have taken a small piece of code actually, that is x equal to a plus b star c. Originally what is happening is, as we know, the first phase is lexical analysis phase. Okay, so we are taking a small example, this one, that is going into the, and we are assuming that this is the only one line code that is going into our lexical analysis phase. Originally what happens, that the whole code, whatever we are writing in either C language or Java language, that whole code is going into the lexical analysis phase. But here, for the sake of understanding, for the sake of better understanding, we are taking only one single line of code and we are going to understand all the phases, right? So here let x equal to a plus b star c. This is only one line of code. This is first of all going into our first phase of compiler, that is lexical analysis. Now as I have told you yesterday, as I have told you in the previous video, what happens in the lexical analysis phase, it is generating the stream of tokens, right? It is identifying which are the identifiers and which are the operators. So in this case what will happen, we are having x equal to a plus b star c. So what this lexical analysis phase will do, it will first of all identify the tokens. So it will identify that tokens equal to, it will count the tokens. So here the number of tokens are 1, 2, 3, 4, 5, 6, 7, 8, including semicolon. Okay, don't forget to include semicolon. So including semicolon, we are having 8 tokens. So it will identify that we are having 8 tokens, and first of all identifying tokens, and then it will identify that how many identifiers are there. Now what are identifiers? The operands, all the operands. It will consider all the operands as identifiers. So here operand is x, a, b, c. These are our operands, and equal to, plus and star are our operators. So what this lexical analysis phase will do is, it will keep the operators as it is and it will convert these operands into, it will understand that these operands are identifiers and it will replace these operands with id. So it will make id equal to as it is, again id plus id star as it is, and id. Understood? It is what it is doing. It is just replacing the operands into the identifiers id, and it is keeping the operators as it is, right? So this is what lexical analysis phase will do. So this is the output of lexical analysis phase, and once it is done, the second phase, it will give this output into the second phase. So what is our second phase? Our second phase is syntax analysis. So this whole thing that is generated, it will go into syntax analysis. Syntax analysis. Now what will happen in the syntax analysis phase? As we know, the output of the syntax analysis phase is parse tree. It will take this as input and it will generate a parse tree. Now let us see how the parse tree is generated. Actually, for the generation of parse tree, normally we are having one grammar. We are given the grammar, and as per that grammar, parse tree is constructed. So here in this example, let us assume that the given grammar is, let me write it here, something grammar. Now what is grammar? Let me write it first and then we will understand. Let the grammar be S gives id equal to e gives e plus t or t, then t gives t star f or f, and f gives id. Actually this formation is called grammar. What happens in grammar? In grammar, as we know, in English, if I take any language, that is English, Hindi, we are having English grammar, Hindi grammar, right? Grammar is thing but a set of rules defined. So in this way, here also we are having grammar. This grammar is nothing but it is also a set of rules that tells us that if I am giving this input, then like if I am giving S as input, it may generate ID equal to E. If I am giving E as input, it may generate E plus T, or this slash is nothing but or, means E might generate E plus T, or E can generate T. Similarly, T can generate T star F, or T can directly generate F, and F can generate ID. So in this way, these are nothing but set of rules. For every grammar, for every specific code or line of code, we are having some specific grammar will be specified to you, and as per that grammar, with the help of that grammar, we will be drawing the syntax analysis tree. Okay, so for example, here let us consider that this is the grammar that we are having, and with the help of this grammar, we will be drawing syntax analysis or parse tree with the help of this. Understood? We have in this lexical analysis, we have already got ID equal to ID plus ID star ID. So we have, first of all, we are having this equation, and secondly, we are having this grammar. So with the help of these two, this syntax analysis phase will generate a parse tree. So what happens in the parse tree? The first step in our grammar, the first input, this is known as starting symbol. So the syntax analysis will start, the parse tree will be started with the help of our starting symbol. So first of all, S will be there. S is generating what? ID equal to E. So S is generating ID equal to E. Now we know that ID is not generating anything because ID is not there in the left hand side. Then we have to see E. E is generating E plus T. So E is generating E plus T. Now again, T is generating T star F. So T is generating T star F. Now we know that F is generating ID. So F is generating ID. Okay. Now we have seen that T is generating again F, and F is generating ID. So this T is generating F and F is generating ID. And then this E. E is generating T, T is generating F, and F is generating ID. Right? T is generating F, F is generating ID. Then here ID is already there, ID itself is there. Correct? So this is the tree that we have got. So how this tree, how we can parse this tree? ID equal to, we have to see only the root, right? While parsing it, we have to see only the root. So if I see only the root, I am getting ID equal to ID plus ID star ID. So I am getting our equation, required equation, that is ID equal to ID. You are getting how we are doing? ID equal to ID plus ID star ID. We are going left to right. So ID equal to ID plus ID star ID. We are getting this equation, the required equation that we are getting. Whatever equation I am having, this ID equal to this, right? This was my required equation. So I have parsed this same equation with the help of this parse tree. This is nothing but this is whatever we have made, this is known as parse tree. Now what is our next phase? This parse tree will go inside semantic analysis phase. This was syntax analysis phase. This will go inside semantic analysis phase. Now what happens in semantic analysis phase? In semantic analysis phase, this will go inside this tree. This whole tree actually will go, right? This is our whole tree. This whole tree will go inside semantic analysis phase. What was the use of semantic analysis phase? It will just check if our tree was semantically correct or not. It will just check if the tree is semantically correct or not. So this is the tree that will be given as input in this semantic analysis phase. It will check if it is semantically correct or not. What do we mean by semantically correct or not? It will check if the precedence, associativity, those things are correct or not. As we proceed in the compiler designer, we will go in detail what does precedence means, what does associativity means, but for here, for a overall abstract understanding, let me tell you, it will check the things like, see, if I am having tree like this, the operation which is at the bottom, it will be executed first. You are understanding? We are having the whole tree, but how the evolution takes place? Evolution takes place from the bottom of the tree. So here, if I check this tree, in the bottom, first of all, id star id is there, so it will be evaluated first. After plus, I am having, after star, I am having plus. After plus, I am having equal to, that is assignment operator. So if I check like that, it is following the precedence. If we know, right, you must be knowing that simple, if I am considering simple mathematics, then we know that multiplication and division, they are having first priority, then plus minus, they are having second priority, then we are having assignment, right? This is the way how precedence increases. So first precedence is multiplication division. So first multiplication is there, then we are having, see, we have to check the precedence of these operators. So we know that first of all multiplication is taking place, okay, because it is having higher precedence, then addition, and then at last assignment. So checking the things like this, if I am checking in this tree, then yes, it is semantically correct. Right, so semantic analysis phase will do these things. That parse tree is already generated by syntax analysis phase, but semantic analysis phase will check if it is semantically correct or not. So in this case, it will check that yes, it is semantically correct. So what it will do is, it will give the same tree. Whatever tree was there, it was semantically correct, it will give same tree back as output, because as it is semantically correct, right? The semantically correct or semantically verified, because the use of this phase is just to verify the syntax tree that we have generated. Okay, so the next phase we are having is intermediate code generator. Intermediate code generator generation or generator, whatever. So what it will do, it will generate the intermediate code, which will neither be high level language nor be low level language. As we have discussed yesterday, intermediate, one of the most famous intermediate codes example is 3 address code, and I have told you what is 3 address code. 3 address code means it will be having 3 operands, right? So that's why it is known as 3 address code. So in this case, I know that my given equation was x equal to a plus b star c, right? My equation was x equal to a plus b star c, x equal to a plus b star c. But as we know, if you see here, we are having 1, 2, 3, 4 operands, but we don't want 4 operands, right? In intermediate code generation, in 3 address code, we want 3 operands. We want 3 operands, but here in this case we are having 4 operands. So we will convert it into 3 address code in various steps. So first of all, how I can do it? I can first take the multiplication. So I will take one variable and store the multiplication in it, b star c. Then I will take another variable and store this addition in it. So this equal to a plus b star c. Now b star c is my t1. So t1, and at last I will do assignment, that is x equal to this t2. So this is nothing but 3 address code form of this equation. This is the 3 address code form. Now this 3 address code will go into our next phase of the compiler, that is code optimization, right? Code optimization. Now what happens in the code optimization? It will try to optimize the code. Here in this case, we have generated the intermediate code of 3 steps. So it will check if it can convert it into 1 or 2 steps. So in this case, we can convert it into 2 steps. How? First step will be as it is, t1 equal to b star c. But these 2 steps can be combined, and I can directly assign this thing to x equal to a plus t1. Okay, these 3 steps are equivalent to these 2 steps. So what I have done, I have optimized this code of 3 lines into 2 lines. So this is the task of code optimization. Now after code optimization, I am having my last step, that is target code generation. What happens in the target code generation? The last step, the task of target code generation is mainly to generate our required form of code. In this case, we will consider that our required form of code is assembly code. Okay, so what it will do, it will finally convert this into assembly code. So for assembly code, let us take, as we know, assembly code is all about registers. All the things are stored in the register. So if for our example, let us consider we are having A, B, C, right? So let me consider something for A, B, C. Let A means R0 register, B means R1, C means R2. If I am consider like this, so the first one is T1 equal to B star C. So T1 equal to B star C means we are multiplying two registers and we are storing it somewhere. So first of all, multiplication. So it will become mul R1 comma R2. What this will do, this will multiply R1 and R2 and it will store the result in R2. Then we are having addition. So add, let me take something else, R0 and R2, because multiplication was stored in R2. So with this R2 I will be adding R0, and at last we are having assignment operator. We have to move the result, because until now we are working in registers, and at last I have to move the result of register into our target variable, that is X. So at last my last step would be move R2. R2 means R2 is having the final result. So we will move R2 into our variable X. So this is the final assembly code generation, target code generation that we require. So this is the whole example how we can convert this, our normal code. It will go through all the phases of compiler and ultimately it will give us the assembly code that is required or understandable by the target. Whatever our target is, it will be understandable by that system. Okay, so this is the whole thing how it takes place. In case you are not understanding anything or you still have any confusion, ask us in the comment section. We will try to help you out. Thank you.